Hello, physics, electromagnetic induction, charge. The magnetic field perpendicular to the single 13.2 centimeter circular loop of a copper wire. So this is copper loop, and this diameter is 13.2 centimeter of the copper wire. The magnetic field perpendicular to a single 13.2 diameter circular loop of copper wire decreases uniformly from 0.750 Tesla to 0. If the wire is 2.25 millimeter in diameter, how much charge moves past in the coil during this operation? So magnetic field is changing. So B initial and B final is 0.750 Tesla to 0 Tesla. So the change delta B is equal to 0.750 Tesla. So we have to find the amount of the current, and the current is related to I. I is equal to Q over T. So that means Q is equal to I T. I especially delta T. And current is related to EMF. So V is equal to IR, Ohm law. So from here, EMF is equal to IR. So I is equal to EMF over R. So from the Faraday law, see, EMF is equal to the magnitude is rate of change of the magnetic flux, B phi B over delta T modulus. So is a magnitude we are calculating, actually is a negative sign. So, and this is equal to the field EMF is equal to the loop, area of the loop time delta B over delta T, rate of change of the magnetic field. So if you want to find out the current, so use this for this one. So I is equal to EMF over R, which is equal to EMF is this one, A area of the loop into delta B over delta T into R. But R is equal to rho, density of the resistance multiplied by L over area of the wire. So this one will be equal to A the loop into R is resistance density into L of the wire, loop of length of the wire over area of the wire into delta B over delta T. Delta T. Or this can be written as I current is equal to area of the loop, area of the wire, rho density of the resistance, L of the wire into delta B over delta T. So this one is equal to pi into R is 12 point R of the loop whole square into pi of and radius of the wire whole square multiplied by R resistivity into this one is 2 pi into loop R loop into delta B over delta T. This pi cancel, this loop is cancel, so it is equal to pi on top, pi by 2, this one into R loop R wire square R row density into into delta B over delta T. This is I, and this one I multiplied by this one I delta T. So delta T is given, so I delta T is equal to Q. So Q, so delta T will go there, and if this one, so substituting the values, pi by 2 into R, the loop is equal to 13.2, and half of it is equal to 6.62 10 power minus 2 meter into this one, this is diameter, and 2.25 diameter is half is the radius, 1.126 1.125 10 power minus 3 meter whole square divided by the density is equal to 1.68 into 10 power minus 8 ohm meter into rate is equal to this one, 0.750 Tesla. So this one, so if you calculate this one, and this will give us the value 5.86 Coulomb. This is the charge. So first use the charge and current. Q is equal to I delta T, and EMF is Ohm law. EMF is equal to IR. I is equal to EMF over R. EMF is given by Faraday induction, rate of change of the flux, and the flux is related to the magnetic field multiplied by loop, and this EMF divided by R will give us current, and the substituting the value of the EMF is this one, and R is this one, and then simplifying this one we can get the formula, final result of the charge, amount of charge in the wire.